How circuit breakers work. Every modern building contains small devices constantly waiting for something to go wrong. Most of the time they do absolutely nothing. Then suddenly, in a fraction of a second, they disconnect electrical power before wires overheat, equipment gets damaged, or entire buildings catch fire. Which means circuit breakers spend most of their existence patiently waiting for electrical problems humans would strongly prefer not to experience personally. So today we are going to walk through how circuit breakers actually work and how electrical systems protect themselves automatically. Circuit breakers are protective electrical switches. Their job is simple. Detect dangerous electrical conditions and interrupt the flow of electricity immediately. Modern electrical systems rely heavily on them for safety. Electric current normally flows through wires safely within designed limits. But sometimes current increases far beyond safe levels. This may happen because of short circuits, overloaded circuits, damaged equipment, or faulty wiring. Too much current creates excessive heat. Excessive heat creates serious fire risks. Circuit breakers are designed specifically to stop that process before major damage occurs. Traditional fuses handled similar tasks historically. Fuses contain thin metal strips that melt when current becomes excessive. Once melted, the fuse permanently breaks the circuit. Circuit breakers improved on this design because they can reset instead of requiring replacement every time. Inside a circuit breaker are electrical contacts connected together mechanically. Under normal operation, electricity flows through these contacts continuously. If dangerous current levels appear, the breaker rapidly separates the contacts and interrupts the electrical flow. The interruption process happens extremely quickly. Milliseconds matter heavily during major electrical faults. Modern breakers may respond almost instantly under severe short-circuit conditions. Many household breakers use thermal and magnetic protection together. Thermal protection handles long-term overloads. Magnetic protection handles sudden large current spikes. Thermal systems usually rely on bimetallic strips. Different metals expand differently when heated. As excessive current generates heat, the strip bends gradually. Eventually it triggers the breaker mechanism and disconnects power. Magnetic protection works differently. Large electrical currents create strong magnetic fields. The breaker uses electromagnets to detect sudden current surges. If the magnetic force becomes large enough, the breaker trips immediately. Which is helpful because electrical systems generally prefer not to explode while carefully waiting for slow heat buildup calculations. Once the breaker trips, internal springs separate the contacts rapidly. An electrical arc forms briefly as the contacts separate. Circuit breakers contain arc control systems to extinguish that arc safely. Otherwise electricity would simply continue jumping through the air. Large industrial breakers become much more complex. High-voltage power systems involve enormous electrical forces. Industrial breakers may use oil, vacuum systems, compressed gas, or special arc chambers to interrupt high-voltage currents safely. Modern homes contain multiple circuit breakers inside electrical panels. Different circuits protect lighting, appliances, outlets, and HVAC systems separately. This isolates electrical problems to smaller areas. Ground fault circuit interrupters add another layer of protection. These systems detect tiny current imbalances that may indicate electricity leaking through unintended paths. This helps prevent electrical shock hazards. Arc fault breakers detect dangerous electrical arcing conditions inside damaged wiring. Modern building codes increasingly require these advanced protections. Electrical systems became dramatically safer because of circuit breaker technology. Most people rarely think about them until a breaker suddenly trips during an inconvenient moment involving microwaves, heaters, or questionable extension cord decisions. Modern electrical infrastructure depends heavily on automatic protection systems operating continuously behind the walls. To wrap up, circuit breakers work by detecting dangerous electrical current levels and automatically disconnecting power before overheating, fires, or equipment damage occur. Thermal and magnetic protection systems help breakers respond to both long-term overloads and sudden short circuits rapidly. Arc suppression systems safely interrupt electrical flow while modern breaker panels isolate faults across different circuits. Circuit breakers became one of the most important safety technologies supporting modern electrical systems worldwide. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.